This is a quick review of Lewis structures and their polarity in anticipation of the chapter on intermolecular forces in the liquids and solids chapter. If anything in this video does not sound familiar to you, I would encourage you to reread the Lewis structure section in your textbook. Okay, so Lewis structures, something that we haven't worked with in a while. You will find I've provided this resource for you. If you need a refresher, it's a flowchart on how to draw a Lewis structure. And so I'm going to do a few examples using this. We count the total number of electrons in the structure. We draw the skeletal structure by determining which atoms are central and which are terminal. We place the bonds in the structure, 2 electrons for each. We identify the terminal atoms, which are the ones on the end of the structure. We complete the octets of each of those, except for hydrogen, which only needs 2. Then we look to see if any valence electrons remain unassigned. If any of them do remain unassigned, we put them on the central atom. Otherwise, if we used all of them up, we check the octet of each atom in the structure, and we push lone pairs in to form multiple bonds as needed to complete the octet of each atom in the structure. And this gives us a satisfactory Lewis structure. So let's use this to do a couple of examples and jog our memory here. So our first example is going to be C2N2. So the first step in the flowchart is to count the total number of electrons in the structure. So we can do that remembering the position of each of these atoms on the periodic table. So there are 2 carbons, and carbon is in column 14, so it has 4 valence electrons. There are 2 nitrogens. Nitrogen is in column 15, so it has 5 valence electrons. And 8 plus 10 is 18 valence electrons. Okay, so our next step is to draw a skeletal structure. If you dig way back and remember, we like to choose the more electropositive atoms like carbon to be the central atoms. So if we choose to put the carbons at the center, and then if we choose to put the nitrogens on the outside as terminal. So we put 2 electrons in each bond in the structure. I guess I did that already. 2, 4, 6 electrons bonding. Terminal atoms, those are the 2 nitrogens. Complete the octets of the terminal atoms. Okay, so nitrogen needs 6 more electrons to have a complete octet, meaning that there are 1, 2, 3, 4, 5, 6, 7, 8 electrons associated with each atom. So now we're going to count and see how many electrons we have used up. So remember that each one of these lines represents a pair of electrons. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18. And we had 18 electrons total, so that means all of them have been used up in our structure. So we don't need to add any to the central atom. So since our answer was no, now we check and see if all of the octets are satisfied. Each of the atoms has 8 electrons touching it. So nitrogen has 2, 4, 6, 8. It's good, and so is the nitrogen on the other side. But the 2 carbons in the center each have 2, 4 electrons. So they do not have a complete octet according to our picture. So the flowchart says if we do not have a complete octet for all atoms, we need to form multiple bonds. So we can take those electrons that are on something that does have a complete octet and push them in to share them with something that doesn't. So let's push in 2 lone pairs from each of the nitrogens. Since we know that the carbons, each of the carbons needs to increase by 4 electrons, we're going to push in 4 electrons from each side. So these check marks are for complete octet. Okay, so let's draw our new structure again, the new bonding. So we pushed in all but 1 lone pair on each side for the nitrogens, and we pushed in enough to form a triple bond here. This is still a single bond, and a triple bond here. So now we'll check our new structure for the octet, 2, 4, 6, 8. We're still good on the nitrogens, and now for the carbons, 2, 4, 6, 8. So everything in this molecule has a complete octet, and this is now a complete structure. And there we will stop. Okay. Let's do another example. Let's do something with a charge this time. All right, so the first thing we do is we count the number of electrons. So nitrogen is in column 15. 1 nitrogen times 5 valence electrons. There are 4 hydrogens. Hydrogen is in group 1. So there's 1 valence electrons for those. And now don't forget to also count the charge. A positive charge means there is 1 electron missing. So we're going to subtract 1 electron from the total. And that should give us 5 plus 4 minus 1. That should be 8 valence electrons. All right, so now we're going to draw our structure. And nitrogen is not very electropositive, but hydrogen is always terminal because it can only form 1 bond. So that means that nitrogen is by default going in the middle. And we'll put the hydrogens all around it. Okay, complete the octets. Hydrogens are completed because they only have 2. Subtract the number of electrons from the total, 2, 4, 6, 8. So yes, we have used all the electrons up. Check the octets. Hydrogen only needs 2 electrons because it only has a 1s subshell, so those are good. And nitrogen has 2, 4, 6, 8. So it's happy, and we'll add in the positive charge for completeness. All right, so that's our Lewis structure for this one. And then let's do one more. We're going to do HCOOH, which is formate. All right, we'll count our electrons. So there's 2 hydrogens here, which are worth 1. There's 1 carbon, which has 4 valence electrons, and there's 2 oxygens. Oxygen is in column 16, so it has 6 valence electrons. So that's 2 plus 4 is 6, plus 12 is 18. 18 valence electrons. Okay, so for our skeletal structure, the way this formula is written gives us some information about it already. So the carbon is listed right next to everything that it's connected to. So this carbon is connected to the H, which is on the left side because it's terminal, and it's also connected to these 2 oxygens in the formula. And then we'll stick that last hydrogen on the end on one of the oxygens. We'll put it on this one. Okay, there's my terminal atoms, these hydrogens, and one of the oxygens. We're going to complete the octet of the terminal atom. So we'll add 3 lone pairs to this oxygen and 2 lone pairs to this oxygen, and we'll check our count. 2, 4, 6, 8, 10, 12, 14, 16, 18. And that was our original count. So all of our electrons are used up. So now we'll check the octet. Hydrogens are good with 1 bond. This oxygen has 2, 4, 6, 8. Check. This oxygen has 2, 4, 6, 8. And this carbon only has 2, 4, 6. So that carbon doesn't have a complete octet, so we need to push in a lone pair from something. And I'd like to push in a lone pair from this oxygen because it has the most number of lone pairs sitting on it. So we'll push one of those in, draw our picture again. Single bond, single bond, single bond. Now we have a double bond here and only 2 lone pairs and 2 lone pairs up here. Check our octets again. Hydrogen only has 2. This oxygen now has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. And this carbon now has 2, 4, 6, 8. So every atom has a complete octet. This is going to be our final structure.